So the Federation of Canadian Municipalities has been the national voice of municipal government since 1901. It fosters the development of sustainable communities to improve quality of life by promoting strong, effective, and accountable municipal government. With over 2,000 members, the Federation of Canadian Municipalities represents the interests of municipalities on policy and program matters that fall within federal jurisdiction. Members include many of yourselves, being Canada's largest cities, small, urban, and rural communities, and 19 provincial and territorial municipal associations. In 2000, the Government of Canada endowed the Federation of Canadian Municipalities with $550 million to establish the Green Municipal Fund. An additional $125 million top-up to this endowment was also added to the fund in 2017. The Green Municipal Fund, GMF, offers funding for plans, studies, pilot projects, and capital projects. So we aim to support you throughout the life cycle of your projects in 5 different areas. So transportation, water, energy, waste, and brownfields. The funding is available to all municipalities, municipal governments, and their partners in eligible projects. And since inception, the GMF has funded more than 1,400 initiatives in over 500 communities across Canada. Our Green Municipal Fund project database is a wealth of information on the projects that we have funded, including case studies, reports, contact information, and more. So I would encourage you to check it out. We'll send a link out in the chat box today. So I just saw the link come up. The Green Municipal Fund is your partner in sustainability to help move your projects forward, and we offer funding, resources and tools, training, networking opportunities, and peer learning. So as you can see, the GMF aims to go beyond funding to support your sustainability initiatives. For example, we have several initiatives focused on building capacity and knowledge in the energy sector. We're in the process of developing and consulting on an energy roadmap meant to help identify common challenges across municipalities, compelling solutions to help close the implementation gap. This roadmap will be published in the fall of this year. Please feel free to reach out to us and share any ideas that you may have on areas where GMF can support municipalities in building capacity and knowledge. We're always eager to hear from you. This presentation that we're co-hosting today with Natural Resources Canada is an example of providing resources and tools in the energy sector. So in our stakeholder engagement, we've heard from many of you that you would like more decision support tools to help you better understand your own unique context, identify the largest opportunities for energy savings and the most compelling solutions. RETScreen is one such decision support tool. You'll be provided an overview of why you should use the software. We also have a representative from the Town of Caledon to come and speak to us as a municipality that has experience using the RETScreen tool and to really speak about their experience and the benefits that they've realized from using the software. So to begin, I would like to introduce our speakers for today. We have Kevin Burke, who is a senior engineer with the Innovation and Energy Technology Sector, Natural Resources Canada. Kevin has a Bachelor's of Engineering from McGill University in Mining Engineering. He has been with the RETScreen team for almost 15 years. He has a passion for making the world better through cleaner energy and finding solutions to help people by developing and using software. He has been able to work at the intersection of both of these passions as a member of the RETScreen team through software development, teaching, and providing technical guidance to people trying to solve their own energy challenges. Kevin has given lectures and workshops to thousands of people around the world, including at the United Nations, universities, and major corporations. Our second speaker today is Christina Guido. She is the Energy and Environment Specialist with the Town of Caledon and has been in the role since February 2017. She has her master's degree in environmental studies from York University with a focus on behavior-based energy programs. Christina recently received the Business Energy Professional Certificate from the Association of Energy Engineers, and as the Energy and Environment Specialist, she is responsible for the development, implementation, monitoring, and verification of processes, programs, and projects related to the management of the corporation's energy and greenhouse gas emissions and environmental performance. So with that, I'll pass over the presentation to Kevin. Thank you.
Thank you very much, E, and welcome everyone. And I'm very happy to get the chance to speak to you today about RETScreen. My goal today is threefold. One, I want to give you an overview of what the software can do, some concrete overview so that you walk away understanding sort of the scope that RETScreen can do for your municipalities. I also want to show the software itself, so I'm going to spend quite a bit of time in the software doing a live example. And then I also want to talk a little bit about the opportunity that you have as municipalities to engage with us and get RETScreen on your desktop so that you can use it. I see in the participants list here in the chat a couple of names I already recognize, so I'm glad that everyone has joined. I thought maybe I'd give a brief overview for those of you who may never have heard of RETScreen or it's been a long time. Just a reminder, so RETScreen is a software tool developed by the Government of Canada under the Department of Natural Resources Canada. There's over 600,000 users who've downloaded and used the software now, and we're growing at about 40,000 new downloads and users every year. And so we have, RETScreen's been around for over 20 years now. It's used for energy efficiency, renewable energy, and cogeneration. It's translated in 36 languages, and we have a lot of funding through our partners, the IESO, REAP, and collaborations with NASA and UNEP and Jeff. RETScreen is financially supported by NRCan, but we do have a cost recovery program in place. So we run a sort of a freemium business model. So we do have a subscriber base who subscribe to the professional mode of RETScreen. So moving forward here, this is the software itself, the platform. For those of you who may have used it previously, either for energy tracking or renewable energy, RETScreen Expert is a new software platform where we've combined all those elements, so from benchmarking and feasibility analysis all the way through performance analysis, and we've added intelligent tools around each of those to help. As he said right at the beginning, it's a decision support tool to help you manage the energy in for your energy projects in your municipalities. And I'll actually be showing this live in a moment or two. Some of you may be wondering who is using RETScreen. So RETScreen really is used, our primary audience are energy managers and sustainability managers, especially for large number of buildings. So we're talking about whether it's right down at the facility level, facility managers looking at sort of the daily or weekly or sort of periodic evolution of the energy consumption of their building. Energy managers who are looking at often multiple buildings and trying to identify and attribute, savings and how those tie in with the energy measures that the organization might be doing, and sustainability managers as well. There's a tight, there's a close relationship between sustainability and energy. So talking about whether it's about water or waste or fleet, so vehicles that might be owned, and especially GHG emissions and tracking and reducing those. The nexus of sustainability and energy is very tight, and it all can be used, it all can be managed in RETScreen. Even though we've been around for 20 years, we have a very, very active development program. We're constantly updating and adding new features to the software. So recently we just released the cogeneration and district energy model and CHP archetypes. We also have a lot of new archetypes, even in the last year, for municipalities, industrial archetypes, university and college campuses, and individual archetypes as well are in the pipeline as well. We also have an API, an application programming interface, which we call RETScreen Connect, which is for the automation and linking of external data sources with your RETScreen files. So that makes when you have to update all your energy bills monthly or quarterly for reporting, that can all be automated. Click of a button, you go get a cup of coffee, and you come back, and all your reports and savings and data is uploaded. In terms of energy and sustainability management standards, we've recently worked with EVO, the Efficiency Evaluation Organization, on their IPMVP protocol, especially under M&V with the options A, B, C, D. We have some articles published on that and tooling in the software to track that. And we've pushed that even further with recent upgrades to ISO 50001 and the US Superior Energy Performance out of the DOE. We have also custom dashboards we've added, and I'll be showing those, and forecast tools. And as I mentioned, we now have fleets and water waste and so on. And we're also, building out the capacity building information. So I know we're going to go quite quickly today, but a lot of you will have more detailed questions. So we have a YouTube channel. We have a series of, we publish a bunch of articles on our LinkedIn pages. If you're connected to either myself or our director, Greg Lang. And we're continuing to add to those. We also have something called RETScreen Enterprise. So RETScreen Enterprise is for facility owners who own more than one facility, so multi-facility owners, to integrate RETScreen into a portfolio-wide energy management. So managing that energy consumption, the billing data, the cost, the analysis on the GHGs on the sustainability side for multiple facilities. So two examples would be, greening of government operations, or GGO, within the federal government itself. So not only are we helping individual departments with their energy management and tracking and normalizing that data, RETScreen is also the tool now, the official tool of Treasury Board to do all GHG reporting for the federal government. And also with the Council of Ontario Universities, the COU, with the IESO funding here in Ontario. So I'm working on that. So 21 universities, about 1,400 buildings, and using RETScreen to benchmark that, to get archetypes in there, to identify promising areas of future projects, and eventually energy tracking and GHG emission reduction tracking as well. So we've released just a month ago the latest version of RETScreen, which, as I said, includes the CHP cogeneration model. In the middle picture here on the upper side, that is the we've advanced the RETScreen Connect, that API that I was talking about. We've now added even further automation and integration with where you can create whole portfolios from data dumps from various tools. So, for example, Portfolio Manager, Helios, Metrics, Urginet, and we'll keep adding more. So, for example, you can go into Portfolio Manager if you have your data there and download your data and import it directly into RETScreen. And again, you go away for go get a cup of coffee or have a meeting, and when you come back, you're going to have a full portfolio, all the facilities, all the energy data, all the weather data downloaded from NASA for the specific locations, all built in. So it's a great quick step that really alleviates and reduces the barrier to creating your portfolio, especially if you have multiple buildings. If you have 3 or 4 buildings, it's one thing. If you have 150 or 400 buildings, it's quite another. And then there's databases that we've updated, and we've added a lot of new features to it. So here is that RETScreen Connect that I was mentioning. So here's the link to Portfolio Manager and these other tools. And the idea is we're continuing to work on ways to make data easily come into the software and out of the software. So whether it's automatically creating portfolios, automatically updating it, because creating it, the first time is one thing, but even more important is to be able to continuously update that data and get your reports and your calculations done, and then to export that as well. We also integrate with Bing Maps, so you can actually geolocate your data, geolocation database. We have a partnership with NASA, which has been, many, many years in the making, where now we're downloading data directly from them directly into the software. As they improve their tool, they just have changed from a 1 degree grid to a half degree by half degree grid. So, 4 times the resolution, the whole surface of the planet. I just tried before the presentation, and the data is already available for Monday. So, 24-hour, 36-hour delay in the data. It's really quite phenomenal. And there's other tools in here as well to help you manage your data. Showing here, RETScreen Enterprise is really, we spend a lot of our resources doing this, guaranteeing success within organizations that have multi-facilities. And so this is a sort of a matrix that shows sort of the breadth and the depth that RETScreen can do for your municipality, for organizations that have multiple buildings. And if I look sort of at the middle row here, that represents an individual facility, and each of those is the level of analysis. So you can use the virtual energy analyzer right at the left-hand side in the middle column there with a map, the virtual energy analyzer to load an archetype for your facilities, and then moving towards the right to do a benchmark analysis. So to say, well, what does a typical, say, arena in northern Saskatchewan, or what is a typical convention center in Hamilton, or what about an administrative building in London, Ontario? And so using our benchmarks and the archetypes, you can do that quite quickly. That, in fact, is a big part of the work that I'm doing with COU, is basically getting archetypes and benchmark data for 1,400 university buildings across Ontario. That's a big project, and it's, but there's a lot of insight that you can gain just from that. But then, of course, if you do have data, you want to, again, moving to the right, do consumption and production monitoring with actual data, and then moving even further to the right in that graph, in this matrix, if you normalize that data to actually start forming the relationships between your energy consumption and the drivers of energy consumption. And then, of course, as you do this, you're going to identify projects. You're going to identify areas to improve, because you'll want to do feasibility analysis for projects to identify what to do and the feasibility of those. And each of those steps is for an individual facility, but if you can do each of these on all of your buildings or a group of them, and then aggregate that into what we call multi-facility analysis or portfolio analysis. So you can do a portfolio analysis of your benchmarks and rank the buildings in terms of their energy use intensity and their benchmarks, see who's underperforming and who's on target. Do portfolio energy tracking, so overall consumption of gas and GHG emissions, overall performance analysis. So as you implement projects across your fleet of buildings or your portfolio of buildings, what is the total aggregate savings of energy or avoided costs, for example, and so on. This is just a subset here of groups and organizations that we've worked with Of course, the biggest one we work with is the Government of Canada, so, working with Treasury Board on their GHG reporting, but also individual organizations. There's also a lot of municipalities in here, City of Sarnia, Town of Caledon, and Christina will talk to us about that, region of Waterloo, and some of you may recognize your facilities here. There's also a lot of school boards. There's a couple of industrial facilities here, CRH and 3M. And so what we're doing here with RETScreen Enterprise is really working with them to get their energy data per facility into RETScreen, working with them to develop those statistical relationships between energy drivers and energy consumption, and then aggregating that so that you really get a good view on the total energy consumption for lots of buildings. So without any further ado, I'm going to jump into the software now. So I'm going to share my screen here. I'll take a moment to switch over. So my screen should be sharing now. I'm going to make sure that I have a little chat open here in case there's a problem, in case you can't hear me or see anything that you can tell me. Okay, I'm getting word that it's fine. Okay, software, this is what it looks like if you haven't seen it in a while. So this is in the middle here is the circle is what we call our project workflow. And often you start with having energy data, and you will collect that in RETScreen and then do analytics on it. And that analyze the total energy performance. And this is where you start investigating, forming those relationships, those baselines according to energy drivers. And then, of course, you want to report, are you actually saving energy or not? And report down to the facility level or up to the senior decision makers. And Christina will talk a little bit about some of the tools they do to do that. And then, of course, then you want to compare that to your other facilities. So doing, identifying where the location is of all your facilities and putting the information about the specifics, who's responsible, and so on. And then, of course, once you start benchmarking, and you're going to have certain buildings that you want to focus on, and then so you can do a feasibility analysis using RETScreen. As we have a virtual energy analyzer here to help you out, and then you can go in and dial in your building and identify promising projects. Of course, once those projects are done, that generates data, and the months following its implementation, you'll want to track your energy performance to see if you're actually saving as much as you said you would. And so you continue through this circle through collecting the data, doing the analytics, and so on and so forth. So it really is a continuous process of managing your energy, and all of these can now be done in RETScreen. This circle represents the process for one building, and if you think of this sort of as a coaster, if you stacked a bunch of these on top of each other, that stack would be your portfolio of buildings. And so you can get a lens through all the feasibility projects or all the performance analysis when you do this process over multiple buildings. And we've streamlined the process to do that. I'm going to focus today on the commercial institutional side, but just a reminder that RETScreen also does power plants, so clean energy projects. We now also have cogeneration and combined heating, cooling, power projects, so heating and cooling, or power and heating, and trigeneration, and all those. Also industrial facilities, so whether it be bakeries or furniture or plastics manufacturers and everything in between. And also residential, whether it be a single-family home, semi-detached, or large residential. We've actually worked with a bunch of organizations. I think some of them might be on the call here to help sort of streamline the energy collection for in the residential sector as well. So as agricultural, so greenhouses and poultry farms and so on. And when we say facility, don't think necessarily that it has to have four walls and a roof, right? You can do a lighting project. This is a pier. Or, we actually see some municipalities looking at parking lots, for example. And then it doesn't even really need to be the whole, it doesn't need to be end-to-end energy consumption. You really can look at just a light bulb, or just changing the windows on a house, or just looking at the impact of solar water heating. And then, of course, now we also have fleet energy analysis, so whether on-road, off-road. We're also working with D&D and other organizations to look at ships and airplanes and all the emissions associated with that. So for a municipality, that could also be important. And RETScreen, of course, can look at existing buildings and energy upgrades or retrofits, but it can also be used right at the beginning of a project to identify promising avenues of doing things and the cost-benefit analysis of that. So I'm going to jump into the software now, and I'm going to use a municipal example. Just to be clear, this is a fictitious example, but I do want to sort of anchor it in reality. So let's suppose I'm working on the energy team for the city of Brandon, Manitoba. And we started collecting the data for the municipal buildings there. And one of the things I want to do now is I'm going to add new buildings to it. So maybe I'm responsible for the energy, I'm the energy manager for the, say for the public safety, so fire halls and police departments and so on. So I'm going to use RETScreen in a realistic-like situation where we're going to go right through all the steps in this analysis and then show how you can use RETScreen for each of those. So so this is an example that I've put together. I actually don't know if this I don't know the town of Brandon that well. So if someone is from Brandon and I'm making mistakes, they are my mistakes only. So when I start, I always like to start with a virtual energy analyzer. So when you download the software, you click on the virtual energy analyzer and this map appears. So this map is where you get how you access the archetypes in RETScreen. And what an archetype is a smart, dynamic template, right? So what I have to do is I have to select what type of project I'm interested in and where I am, and that's enough information for RETScreen to be able to calculate the energy performance for that particular building. So let's look very briefly at some of the facilities I can do. So I can look at power plants, and under power plants, I can look at whether it's renewables, photovoltaics, or hydro, or wind turbines, and other sort of stationary power generation, and different capacities as well. This will influence the efficiencies and the costs. And so you'll see that there's in all of these archetypes, they're all fully costed out. We also have here what we were talking about, the new cogeneration and district energy archetypes as well as industrial and commercial institution. On these, you might recognize this list is the same list as was on the homepage. So let's look under commercial institutional. We have, education buildings, for example, or we might have public buildings where we could look at arenas and community centers and convention centers. Let's focus now on the example that I want to do, where we're going to look at a fire hall in Brandon, Manitoba. So let's go to public order and safety, and we have fire stations and police stations. I'm going to click on fire station. I'm going to type in Brandon, Manitoba here, and it brings me right to the city using Bing Maps. And so I'm actually going to zoom in, right? And it's important to really locate your project quite well. And so I know actually that this is a new fire hall in Brandon. And so I'm going to put my little pinpoint here on the map. And that's actually all I need to do. So I've selected what type of archetype, what type of project and facility this is, and I click on calculate. And now what RETScreen will do is it will load the archetype, it will load the climate data, and run the model and do all the calculations to calculate what the potential energy savings are. So that's it, I'm done. So we've only been doing this for a couple minutes, and I've already done a basic pre-feasibility analysis based on the archetype for a fire station. And now what you can do now is when you would start then refining this and adding data so that it is your real archetype. So the first thing I've done here is I have my map, which I located, along with the climate data that was automatically loaded into the software, and a map here of or a graph of the various items from my climate data. So this is climate data. These are long-term averages, and these drive the energy modeling that is the main part of the archetype. So if I move now on to the facility page, the facility page is already started to be filled in from the archetype. You see I have a basic sketch here. We could replace this with a photo of our actual building. And, now is when we would start filling in the data. So we would say this is the Brandon Fire Department, and this is Hall 1, for example. And we could put in other information. So the name of the person who's responsible. So suppose it was me, and their email and phone number. And you could put other things here, like the year built, for example. I don't know when it was built. Let's suppose it's 2007 or something. And you can keep adding information here to really start documenting your facility. This then becomes available in the portfolio, so you can have a database of the location and the information for that building all in one place. So that's important to have as well. The next thing that RETScreen has done is using the archetype, it has already put in benchmark information as well as modeled a base case and a target that, so that it can calculate a proposed case. And you'll see here that this information is reflected in this graph. So the benchmark database has been used for typical fire halls, and we see that where the benchmark is at this level here, 291. And using the archetype, we see that the energy use intensity for this particular one is 418 kilowatt hours per square meter, and that we have a target of minus 47%. You'll notice that we can have multiple targets as well. So suppose that we have a target that is, it's called, let's say it's a target 2040, where we're want to reduce our energy consumption by 40%. And then so we select 40%. And we might have another one that's by target 2050, where we want to reduce by 75%. So we can put in various targets like this. And then so when we choose here, we have the selection of which target we'd like to be. And you can see here that RETScreen, this graph on the right, shows us where we are. So we can say, well, what if we wanted to be minus 80% or 25%? And so we can choose our target here. We have also put in the facility size. This facility size is the archetype. So one of the first things we might want to do is change this to our actual facility size, and maybe our building is 1,350 square meters. And so RETScreen will then recalculate what the base case and proposed case fuel consumption would be based on these the base case and proposed case energy use intensities. And you'll also notice that this is a fuel consumption benchmark, but I also do have emissions benchmark and cost benchmark as well. So these are very important. So for example, with our work with Treasury Board and the greening of governmental operations, the emissions benchmark is very important as well. Let's keep on moving. I'm going to go to the energy tab now. And the energy tab is kind of the guts, if you will, of the archetype. It's a full facility that's been modeled, including a base case and proposed case or proposed measures, and then including costing of those measures. So this is an archetype of a fire hall. And just to be clear, it's not my fire hall. It's not the one that I selected. But if you took every fire hall in Canada and took the average, it would be pretty close to this. So this is a typical or archetypical fire hall. And all I need to do now is I need to then go in and tweak this so that it's it can be modeled to my fire hall. So I like to say that the archetypes get you between 50 and 80% of the way towards modeling your building. So for example, fire halls all have heating systems and cooling systems. They all have building envelopes, and usually two different ones. They have a garage with big doors and an office or a common area. They have ventilation system and lighting systems and motors and hot water and so on and so forth. And each of these is modeled for a base case and a proposed case. So let's go into that. So here we see in the garage area, there's a base case that's T8s, and the proposed case there is to move to LEDs. And so now what you would do, or what you could do, is if you want to refine this to match your building, you say, well, I actually have T5s already, and we're thinking of going to LEDs, and I don't have 34 fixtures, I actually have 61 fixtures. And you would then go and do this and make this archetype your own. But the bulk of the work is already done for you. And RETScreen automatically calculates the savings. So if I go up now a level, so this is an individual lighting project. But if I go up a level into this view, this is what we call the include measure view, where those lights were just one among many, many projects that I could do. And those projects that I've selected are selected here using this checkbox on the right, so I could decide whether or not I wanted to do certain measures or not. And you'll see that RETScreen calculates dynamically the overall payback and the overall cost. And this includes any crossover effects, so the heating effect from changing to more efficient lights, or the waste heat off of motors, and so on and so forth. Okay, so I won't spend too much time more on this. We could really get quite detailed in going to this, but suffice it to say that we've used the archetype now in our analysis of this Brandon fire station, and now we want to focus on the data side of it. So on the data, I'm going to skip over the cost sheet, the emissions sheet, so the emissions associated with the energy project, also the finance, so all those costs and the energy savings, what's the financial viability, the payback and the internal rate of return and the net present value for those, and also risk analysis to see where are the most sensitive parts of my project and where should I focus my efforts if I plan on pursuing those. Let's move to the data part. So the data part is where we're now going to start collecting the data for our fire station. So you'll see here at the top, I have different consumption or production tables that I can have. So my building has electricity consumption, so I would click this button and a table appears for electricity consumption. And now I would start importing data into here. Fuel consumption. My building is heated, and it's heated by, say, natural gas. So I would select various fuels in different units, and let's suppose that my building is heated by natural gas measured in, say, gigajoules, and then RETScreen as that table, and I would add it. You'll see here we have also district energy, so chilled water and hot water and steam. We have transportation as well. So here's where you would put in your vehicles for your municipality that you have and track the energy for fuel usage, as well as waste now. So whether it's sewage or recycling, compost, landfill, that's another thing you can track as well here. And water consumption as well. Clean municipal water supply. So that's what's being consumed. The other thing that you need to notice is that, so these are empty tables now, so how would you get the data in there? So, you could type in the individual data, but what you really probably would want to do is import data. So if your utility has a data available in green button, you can automatically import that. Then you can also import from file by clicking on this and importing a variety of Excel or CSV files. And RETScreen does a pretty good job of identifying what's in the columns or the headers and parsing that out. And so this is the main way that you get data into that. And just jumping ahead, when we're talking about portfolios and RETScreen Connect, this is actually one of the big things that RETScreen automates, is automating the import of all of these data points for all of your buildings, for all of your utilities. So that's a huge time saver as well. The next thing we probably want to do is, instead of just looking at electricity consumption, we want to know what the factors of influence are, what drives energy consumption. So one of the big ones will be weather. So the weather, how cold or hot it is outside will drive whether my building is in heating or cooling. And so RETScreen has a weather table. And once you're on a weather table, you'll notice that you can automatically download data from NASA if you to get that. So that, as I mentioned, was our collaboration with NASA. That's near real time. It's about a day behind, and you can get that data automatically into the software. Occupancy is also a huge energy driver. We see that a lot with arenas and schools. Schools in the summertime may have an occupancy of close to zero, whereas in September and October, the school is full. That's another big important energy driver. So buildings can have also multiple factors that influence its energy consumption. And so RETScreen can take that into consideration as well. You can do multi-factor relationships with your energy consumption. So I'm going to, instead of showing you how to import all that data, I have a couple of examples here. So here I've already started to collect my electricity data. I have some weather data here. And one of the things I would want to do now, for those of you who do energy management, is calculating. What I'm concerned with is not so much the temperature, but whether my building is in heating or cooling mode. And the way that's done is through something called degree days. And there's a certain calculation to do that. And RETScreen has a degree day calculator. So if I click on degree days here, you'll see that RETScreen can calculate heating degree days or cooling degree days, and it will automatically do it on different methods and different reference temperatures. So if I just keep these the default and click OK, RETScreen will then create that data for each of those days. Now notice that each of these, this is daily data. So for every day I have the temperature, the heating degree days, cooling degree days, and there's also a lot of other data that you can download from NASA that's automatically in here. And so if I want to sort of make the relationship between my heating of my building or the electricity consumption of my building and what the heating or cooling degree days are, I need to make sure that I'm only looking at the correct days within the window of my energy consumption. Let me show you what I mean. So I have daily data here, and if I go to my electricity consumption table, you'll see here that the duration between the beginning measurement and the end measurement for my electricity consumption varies quite a bit. So I have here a measurement of 33 days, here's a measurement of 29 days, here's a measurement of 30 days, and so on. So these are uneven periods. So it's important that if I want to find out what the energy what's driving this energy consumption for this period, that I'm using the appropriate heating or cooling degree days for only these 33 days. And so doing this type of aggregation is a very important thing, and it's done really at the click of a button in RETScreen. So what I'm going to do is I'm going to click Merge, and I'm going to tell RETScreen, I say, into my electricity data table, go get the data table called Weather NASA, and take that heating degree day or cooling degree day data that I just had, and merge that into here. So I'm going to click OK, and RETScreen will automatically aggregate according to these periods what it'll sum these cooling degree days for these 29 days, for these 30 days, et cetera, et cetera. Okay? We can go on and keep adding factors of influence and merge them together, but what we really want to do is start analyzing this data. So I'm going to go to the analytics page here. And analytics, the first thing that we'll look at is sort of just look at the raw energy consumption. So just looking at that consumption period here, aggregated per year. So we can see that my reference year is the 2011-2012 year. And I see that the total energy consumption decreased for the first 2 years. And then, it increased in the 2014 year. And just remember, this isn't really the Brandon Fire Hall, so this isn't necessarily what actually happened there, but just to illustrate that you can really get an idea of what happened in terms of energy consumption. Now, the one thing we don't know, though, is why this happened, right? Why did we have a higher energy consumption here? Maybe it was really cold or really hot. Maybe they had a lot more calls. There's a lot of factors that could be the reason why this is. So this data is not normalized. This is just raw data. Nevertheless, it's still important because if we want to compare to our benchmarks and our baseline and target, those are very important. So you'll see these horizontal lines here, our benchmarks and our target and our baseline. We can see where we want to be. So this baseline is this greenish line here, and we're in this particular case, the target is below where our current consumption is. So what we really want to do now, though, is we might want to say, okay, well, let's find out why the energy consumption went up here. And the way to do that is by creating a baseline. And there's a couple of different ways to create a baseline, but the one that we have available and we found very powerful in RETScreen is what's called a regression analysis. And a regression analysis forms a statistical relationship between the energy consumption and the energy drivers. I'm not going to go through creating a regression right now. I'm going to show you an example already done. So here's that building, and this regression is already done. So you'll see this example, we already have done quite a lot of analysis here. And so here I have this regression analysis between the natural gas and the heating degree days, which we've already calculated. And I see that I'm doing this regression over 1 year. So I'm establishing my baseline over 1 year of data. And I can see that this graph shows a scatter plot of the points where, for a given heating degree day, what the fuel consumption would be. And there's a statistical relationship, a line that's drawn that does a best fit between those lines, right? Now, the beauty of having a baseline is a baseline then becomes a prediction tool. So what we can have with this baseline is we can now say, okay, if I know this relationship, if I say this is what the relationship is of heating degree days to fuel consumption or my energy drivers and my energy consumption, I am now in a position to predict. So suppose that on a given day, there are 20 heating degree days. If I follow that up to this line, I can see that it would be about 260 cubic meters of gas consumption for a day, a cold day where there was 20 heating degree days. And so if I'm actually measuring my energy data, if I have less than 260, it means that I'm saving energy compared to my baseline. And if I have more, it means I'm not saving energy. And so that is all summarized in this table below here, where we can see what the actual fuel consumption was and what the predicted amount was. And so the difference between those is going to be savings when it's negative, and it's going to be overconsumption when it's not. That difference between your predicted and actual consumption tells you a lot about how your building is performing. If you take that difference and you add it for the next month, so the next month you take the difference between what you predicted and what you actually did, and you add that difference cumulatively, you end up with something called a cumulative sum of the differences between the actual and predicted energy consumption, or a Q sum, a cumulative sum. And if you put those all together and put them in a graph, it shows something like this. So this graph tells us a lot because this flat part up here is our baseline, and then when this graph goes down, the cumulative sum goes down, it means we have a negative number or a energy savings. We have less consumption than what we predicted. So when this graph points down, we know that we're saving energy. And when it points up, we know that we're consuming more energy than we predicted. The nice thing about a Q-sum graph is every change in direction here really tells you something happened. So you'll see there's a wavy pattern here. And if you look at it a little bit closer, you'll see that these wavy patterns happen during the season. So we can tell when we're saving energy and when we save a little less. You can also overlay information on these graphs and try to align when projects happen. So in this case, this is a real example. There was a new boiler was installed right at this point here, and we can see the effect that that new boiler had. It really seems to be one of the main reasons for this energy energy savings. Another way to look at the difference between the predicted and the actual energy consumption is called an M&V graph, a measurement and verification graph. And this is that same information just presented in a different way. The blue line is what we predict from that equation, from that relationship, and the green line is what our actual energy consumption was. So any space in between the green and the blue on this graph is our energy savings, right? If you do M&V, you need to produce a graph like this that says when the project was commissioned, and that clearly shows what the net savings were as of the commissioning date. So you'll see here that we have a bunch of different graphs. We have a bunch of bar graphs. There's a lot more that we've done here. One of the things that we can do as well, so you'll notice we have electricity and natural gas consumption, so we can aggregate those as well. So we can look at the aggregate fuel consumption, and since we've done predictions on each of them, we can see the aggregate savings normalized to weather. So we can see here that the tall bars are the predicted amount, and the green bar is the actual, and this short bar here is the savings. So this is total fuel consumption, electricity and natural gas. And we can also do that on GHG emissions, so find out where the GHG emission savings are from both natural gas and all fuels, since we do have the emissions factor for natural gas, and we can get the emissions factor for electricity. That's already built into RETScreen. Since we put this project in Manitoba, we can get the emissions factor from Manitoba. The other nice thing that you can do is, since we have this regression, this relationship, we can use it as a prediction machine to do forecasting. So we get this question a lot, and this has been in RETScreen now for at least a year, but sometimes people aren't aware that it's there. You can, if you have a relationship, you can then create a forecast in RETScreen to forecast what your consumption would be. You need to tell RETScreen what the heating degree days and cooling degree days for your relationship would be, and RETScreen can come out with a forecast. And this is what a natural gas forecast would look like. This is a natural gas on consumption, or you could look at the natural gas or the electricity forecast. So this is great to do predictions. So this is a forecast for electricity consumption, but I could very easily switch this to, let's look at the costs or the emissions. So for budgeting purposes, so RETScreen will automatically calculate the heating degree days, cooling degree days, and even the unit cost of electricity or natural gas. And we can now plot have a budget prediction for your forecasting. Another thing that we've done in RETScreen is we've added more reporting tools. So we have a full reporting tool over here that is, a full professional report that you can customize, but we also have one-pager reports as well. So any of these graphs or tables that I've shown, you can also put in a one-page report and then have this, printed off as a PDF or sent by email, or even have as a kiosk. We have some organizations who are working to digitize these and have them in screens in the lobby of their building. So for example, this would be a facility manager's senior decision-makers report who might want to be interested in overall, are we achieving our targets, and look at an annual basis. We might want to drill down a little bit and start looking at the data on a normalized basis and see sort of what the total cumulative fuel cost savings are. And we might really want to get down to the building itself and have sort of energy tracking and line up events or projects that have happened on that site and see what happened, so that the people on site who are responsible for running that building really have the tools they need to really track the energy of their building. Okay, I'm going to back up a second here and go back to this home page. So I have gone through this whole circle. We have loaded, using the virtual energy analyzer, we've loaded an archetype. We quickly saw how it gets us up to 80% of the way towards modeling a feasibility for our project, and then how we can collect the data and run very advanced analytics on that to help identify why things happened. It's good to know what happened, but it's also important to know why and what next. And then the reporting tools and the dashboards. And we saw how that links in with the benchmark data. And so we've done this for one facility, right? But remember in my scenario before, I said, suppose we're the town of Brandon, Manitoba, and we're starting to do this for all of our facilities. And so we just did this for the fire hall, but we already have some other buildings. So I'm going to show you now. I already have here a small portfolio that I've started to build for Brandon. And you can see I already have 4 buildings in here. This is a sub-portfolio or a subgroup of a larger portfolio, which includes all sorts of different types of buildings. And so what I can do is I'm going to add my fire hall to this. So I now have 4 buildings. And so I'm going to go to import. And I'm going to find my file here. Let me just pull it up. And so my file is right. This is my fire hall here. And so you see now I have a 5th building here. And if I go into the maps view, you can see that because I took the time to geolocate all those facilities, here's all the buildings that I have so far. And of course, we would add them over time. So if I hover over it, I can see that there's a workyard and warehouse here. There's a healthcare facility here. This is the police station. Here's the museum. And way up here is my fire hall, and that's the same building that I had. We can go into satellite view and really see that, yep, that's the building that we have, the Brandon Fire Hall. And we've gone in and we've merged into this portfolio the rest of the building. And so I can, that facility. So I can see what the total facility size is. I can right click and say, well, I'm now modeling 11,600 square meters worth of facility space. And now what I can do is I can do an aggregate analysis of these. So if I go to the dashboard view now, I can now run my analysis on all of those, say, municipal facilities. So here I have, this graph here is the consumption summary, the fuel consumption organized by facility name. So we see here for each of the fiscal years a bar graph, what we call a stacked bar graph, that shows what the fuel consumption was. And so if I hover over it, I can see a breakdown here of the various total fuel consumption. So this would be natural gas, this would be electricity, it would be any district heating, everything. It's all aggregated, right? And so you could also go in and look at by fuel type. So instead of looking on a per building basis, well, where is most of the energy consumption held? So here we can see that it's most of the energy consumption is happening from electricity, 9 million kilowatt hours, a little bit more from steam, 3 million, 5 from steam, and natural gas is 3 million. And we can continue down the chain like this. We can look at, say, GHG emissions. So here I have this bar here where I've said is a reference year. This is my reference year where I need to achieve my my reductions for GHG emissions. So I can see here at any given year what the total GHG emissions are. And in the table here, when I'm hovering over, I can see what the difference between the my base year, my 2005, 2006, and the year that I'm hovering over what I am. So I can see here that this is a 14.6% reduction based on my base year. A thing to remember too is all of the data that is graphed up here is available in the tables below. So all of this data comes from these tables, and if you click on this little expander details button in the table, you actually get a full view of all the tables, which you can actually export export onto the clipboard and paste into Excel or any other program that you want to do sort of further analysis. So all this data and all these tables are available to use however you want. Another way that we can look at our data is, remember, we bothered to make those relationships between the actual energy consumption and the predicted. So we can look at the aggregate predictions and the aggregate actual to sort of see where the total savings are. So this graph is, remember that bar graph that we had? It's for all of them. So we have here the total predicted and the total actual and the savings for all of my buildings. So I'm going to stop here talking about showing the RETScreen software. I think we'll pass it over to Christina now, so you can see what a real example of this actually being used in a facility, for a municipality, what that looks like.
Thanks, Kevin. I'm just gonna, oh, there we go. Hi, so I'm Christina. I'm with the Town of Caledon, and I'll be talking to everybody about how we use RETScreen Expert. So I'll just start by giving a quick background of our corporate energy profile here at the town, background on how we started our benchmarking initiative, what we use RETScreen for, and then some of the benefits. So I just thought I'd start off with sharing where Caledon is. I know we've got lots of people joined from across Canada, so you might not know exactly where we're located. So we're the most northern municipality in the region of Peel. So if you see the map on the lower right-hand side, we're just the top municipality there that I've pointed the arrow to. Our population is about 71,000, and we're expected to continue growing. So just a little bit about our corporate energy profile. So required by the province of Ontario, we have a 5-year corporate energy management plan. So that's set to expire July 1st, 2019. But the target for this plan is a 9% reduction below 2012 levels by 2019. So we have a corporate energy team, and that's made up of facility staff from all levels. And I work very closely with them to manage energy in their facilities. Just so you have an overview of what our building portfolio is here at the town, we have 28 facilities of various types. So you can see in Figure 1 what those types of facilities are, with recreation and administration facilities making up the bulk of our energy use profile. And all of our 28 facilities have models made in RETScreen Expert, which we call our building benchmarking initiative. So this is a slide I use to show the corporate energy team when explaining what building benchmarking is. So basically, it's the process of comparing our facilities' performance independent of the factors that drive consumption in our facilities. So an example of that being weather. So I guess there's two main approaches to benchmarking. One being comparing against other similar buildings, and the second comparing energy performance against our own historical use. So that's the way that we benchmark here at the town. So why did we start this initiative? We really wanted to start quantifying our progress towards our corporate energy target. And we wanted to find a way to better provide feedback to our facility staff on how they're consuming energy in their facilities and what those drivers are. We wanted to be able to identify trends and opportunities to improve, and then celebrate the successes in our facilities. So I won't go into too much detail of how we got there, but basically we began by collecting all of our energy data from 2012 and doing a quality assurance check. So the quality of our utility data back in 2012 wasn't so great. It required a lot of attention, but moving forward, I think towards 2014 is when that data quality began to get better. We met with our facility staff to better understand the equipment that's being used in their facilities. We developed our initial RETScreen models, and then we underwent a peer review exercise with Stephen Dixon just to do the quality check that we were doing our models correctly. And then we worked very closely with Kevin and his colleagues at Natural Resources Canada to create our building portfolio using RETScreen Expert. Oh, so I think the animation is just covering this slide a little bit, but basically the data inputs that we load into RETScreen. So you can't really see it, but we have our utility bills from 2012. We import NASA weather data, and then we import facility characteristics such as booking or ice days. And then this slide in the middle here, the drivers of energy use, really outlines why we have to normalize energy consumption. So for example, weather, it's highly variable and we don't have the ability to influence it, which is why we have to look at the energy consumption in our facilities without the influence of weather. So the three main ways that we use RETScreen Expert, which I'll go into more detail in the next slides, is to provide energy performance reports to our corporate energy team or facility staff. We use it to report back to council on progress towards our corporate energy target, and we use it to inform our internal energy awards. So this is just a screenshot of our energy performance reports that I put together for our corporate energy team. So it's basically a 3-page document where majority of the graphs are directly from RETScreen Expert. So I'll go into more detail in the next couple of slides of what those key analysis are that I share back with them. But the main benefit of this is that it allows facility staff to be in the know of their energy consumption. And it's really great to show the impacts of their operational improvements and the retrofits that we undertake in their facilities. And I also assign a cost to those savings and or increases of energy use in their facilities. So the first graph that we show, which Kevin already gave a great backgrounder on, is the predicted versus actual energy consumption. So we show this to facility staff on an individual facility basis. So basically, as Kevin said, that blue bar is the predicted consumption that contains all of the variables that influence energy in their facilities. The green bar is their actual consumption, and the purple is the difference or the savings. The second graph that we show is the QSUM, which Kevin also gave a great backgrounder on. So the way that I describe this to our facility staff is that it's the storyline of energy consumption in their facilities. So we really use this to look at the trends of energy consumption, and we pinpoint it, or the QSUM allows you to pinpoint it to a particular date, and we can use that to inform a discussion with facility staff to find out either why there were savings in their facilities or why energy use increased in their facilities. So the QSUM that I have a screenshot here is for the Caledon East Community Complex. And you can really see using the event tracker how adjustments made to the arena heaters and dehumidifiers really started to allow the energy consumption to trend downwards, which resulted in savings in this facility. And then you can also see once we installed the Simco 6000E controller on the ice arena, how that continued to show that downward trend of energy consumption. The monthly cost avoidance graph, this isn't one that I use directly from RETScreen, but I use the data from our QSUM to assign the unit cost of electricity and natural gas on the avoided use so that facility staff can see the direct influence of the operational and retrofits, assigning a cost to it. So they can see that by saving energy, this is how much of avoided electricity costs that they had in their facility on a monthly basis. So the second piece that we use RETScreen for is reporting back to council. So now this predicted versus actual graph is on the building portfolio scale. So this is with all 28 facilities in the town's portfolio. So we report in line with the province's required annual reporting of energy consumption, which is 2 years behind. So our most recent is 2016, but in this July, we'll be reporting back on our 2017 consumption. So you can see that we are on track to meet our target of the 9% reduction. In 2016, we achieved that 7.82% reduction. So we use this to inform that council report, and then we'll also share with council the main energy initiatives that we undertook that year to justify these savings. And the final piece is our internal corporate energy awards program. So we just introduced this year 2 new award streams, which is the Electricity Performance Award and the Natural Gas Performance Award. And the data behind these awards are driven from the results of the RETScreen Expert models that we have. And this is also a great way that we get our senior management team involved. So you can see here on the bottom 2 photographs. It's actually our General Manager of Finance and Infrastructure Services who's distributing these awards to the facility staff that have won them. So it's a great way to recognize facility staff for all of their hard work and their efforts on conserving energy in their facilities and getting that involvement from our senior management team. So there's many benefits to using RETScreen Expert at the town. It's a great way to measure the impact of the town's corporate energy program. We're able to identify high-performing facilities and identify facilities that require additional attention. We now understand better the energy drivers in our facilities. Through the QSIM, we can detect avoidable energy use. We're able to involve our senior management team and report back to council. And it's expanded our in-house skill set and demonstrating value of the Energy and Environment Department. And here's our contact info. So mine's at the bottom, and I've also provided my manager's contact information above. If you have any questions at all about RETScreen or how to use it, I'm definitely happy to speak with you.